Hi guys! So I am going to show how to find the volume of a solid using the shell method. Everyone usually learns the shell method last. Before that they learn disks, washers, and cross sections for finding volume. So then by the time they get to shell method, they're like, why do I even have to know this? I'll just use one of the other methods. But there actually is a really valuable reason for knowing the shell method. I'm going to show you this example and then tell you what that reason is. So in our example, we have this shaded region, which is between these two curves here. The problem has given us the curves in terms of y, because they're both x equals with y in the equation. And so to revolve it about the x-axis, I actually need to get rid of that shading so that you can see what I'm doing. Okay, so, but you can see where the region is. If we're going about the x-axis in the shell method, I want you to draw a line in the shading anywhere that runs parallel to the x-axis. Okay, so I've shown that. Now what's going to happen is I'm going to revolve that line segment around the x-axis in such a way that I'm going to get cylinders. So just imagine like if that was revolving around and I was doing that all the way across, I would get one big cylinder shape. Here's how you set up the integral, however, for the shell method. And I'm going to write it in words. You integrate 2 pi, which you could put in front. And then you integrate the distance. This is not how it would be written in a book, but distance from your segment to the axis of revolution and then you're going to times that by the length of the segment and that's it. Okay, so now in our picture, the distance from our segment to the axis of revolution would be, I'm going to highlight it, it would be this distance from here down. Now, a way to label that would just be to call it y. Because no matter where I draw my black line segment, the distance that it will be from the x-axis would be the same thing as the y-coordinate. So this right here in our current problem is just going to be the variable y. So far we have 2 pi y. Okay, now we just need to figure out a way to write the length of the segment that I drew, which is from here to here. Well, since it's a segment that's running horizontally from right to left, we're just going to do right minus left, just like you would have done in easier problems that are disks and washers. So the curve on the right is y squared over 2. And the curve on the left is that other one, y to the 4th over 4 minus y squared over 2. But since that's a quantity, I should keep it in its own parenthesis like that. Alright, so this is an expression showing the length of that line segment. So if I put this all together, I have 2 pi. We'll come back and put limits in. Y times y squared over 2 minus the quantity y to the 4th over 4 minus y squared over 2 dy. And the limits of integration would be the y coordinates, because this whole problem is in terms of y, the y coordinates of intersection. So I'm trying to make this a nice big point. You can see that the curves are crossing at 0, 0. and they're crossing again. I'll make this bigger. They're crossing at 2, 2. I'm going to, it's kind of misleading because the x and y are the same in both of these coordinates, but you're using the y coordinates. So you're going to say from 0 through 2. And then you can just do this on the calculator. So on the calculator, we'll punch this in and get the answer. You get 8 pi over 3. And that's that solution. Now I'll show you why knowing the shell method is so valuable. Okay, this is why the shell method is valuable, because imagine if we had this curve, a very simple curve, y equals x squared minus 3x plus 2, and the region shaded in yellow is the part that we're going to revolve, and let's say they want you to revolve around the y-axis. So if you're going to do it just the regular way with using discs, you have to draw yourself a radius that runs perpendicular to the y-axis, and if you do that with discs, I'll just write it here, you're going to have to integrate in terms of y, because you are going from right to left around the y-axis. So you would have to have the equation written here in terms of y. But look at our equation. That is not going to be easy to get the x alone, because it would have to say, we'd have to transform it so that it would say x equals something with y in order to do it with the disk method. And that is just, it's not going to be easy to do. We could do it, we would have to complete the square, but we're not going to do that. We are going to take the easier route, which is using shells. The reason shells are easier, let's just erase this. So here's our shading again. The reason shells are easier is because we draw a line segment parallel to the axis of revolution. So since we're revolving around y, I can draw a line that runs parallel in the shading, and then it's going to get revolved around the y-axis like this. Alright, but the key here is that since I drew a line segment that runs vertically from top to bottom, the length of that line segment can be written in terms of x. And that is how our equation is written anyway, and so that makes this whole problem immensely easier. So remember, from the front page I said we integrate 2 pi times the distance of the line segment to the axis of revolution times the length of the line segment. Okay, that's just putting it in words. So if we do this, we will have 2 pi, come back and worry about our limits. The distance of that line segment to the axis of revolution, that is from here to here, which is just, it's x away. The line segment, no matter where you draw it, would be a distance of x away from the y-axis. And then you multiply that by the length of the line segment, which, to do that, we'll have to just subtract top minus bottom, since now it's running up and down. So the top of the line segment is on the curve, so that is x squared minus 3x plus 2. And the bottom of the line segment is touching the x-axis, so that's just minus the bottom, which would be minus 0. And then this is all in terms of x, and then we would just need the limits of integration. So the lowest x in the shading is 0, and the largest x in the shading is 2. It goes from, I'll write it over here, it goes from 0, oh, it's not 2. It just looked like 2. It goes from 0 to 1. Okay, and that's what we would integrate. I'll do that on the calculator and just write in the answer for you. And that comes out to pi over 2. Okay, so I'll just put a little note up here. The most valuable time that you will come across, so the most valuable time to use the shell method is when revolving about the y-axis. If you'd like to keep everything in terms of x, which by default is usually how they give you equations and whatnot. So if you want to, like if it's a problem where they did that, they gave you the equations like normal in terms of x, like this one, and you have to revolve your region around the y-axis, and you want to just leave everything in terms of x, revert to the shell method. Just use that shell method, and you don't have to then change things to be in terms of y, which is how you would have to do it if you did the discs or washers method.